Charles Steinhardt. I'm one of the PIs of Buffalo, along with Mathilde, and I'm at the Cosmic Dawn Center, a new center that we've started in Copenhagen as part of the Niels Bohr Institute. And I have a very wide variety of research interests, but the one that drives me to Buffalo is that there's a series of sharp problems where we're learning fundamental things we don't understand about the assembly of the first galaxies and then about their subsequent evolution. And we're hoping that Buffalo is going to be the key to helping us solve many of these problems. I've taken maybe a different career path than many astronomers in that I work on a very wide variety of problems. So I've worked on, in addition to astronomy, problems in computer science, in high energy physics, even in statistics, and also many different areas within astronomy. This actually may not be the best career advice in the sense that often when one goes to hire an astronomer, you're looking to hire somebody to work on a specific project. And so somebody with a more straightforward background could be a better fit. But scientifically, it's a lot more fun. And one of the things I've come to realize is that the most interesting problems in science often are not solved by somebody being that much more clever than everybody else, but rather by somebody looking at the wide variety of problems that people are solving in different areas of science and all of this knowledge that humans are developing and making connections that weren't there before. And this is actually part of how the frontier fields in Buffalo were put together. That the main reason this has been such a successful idea is because we realized that the same exact observations that are needed to look for high redshift galaxies are the observations that are needed to learn about clustering and mass distributions in dark matter. So one of my major goals for Buffalo is to really bring together these groups that are working on related problems because they're all in the frontier fields, but in very different ways. So it's important that Buffalo not be a lensing collaboration and then a high redshift collaboration that just happen to sit in the same room once every few months, but really to recognize that doing this science correctly involves all these groups working together. This is one of the things that Mathilde's been wonderful with on the lensing side, that there were times that there were many different competing lensing groups with competing lensing models, and it's been possible to bring all of those together in Buffalo. And my hope is that we'll be able to do the same thing on the high redshift side and take groups that have thought about each other primarily as competitors and turn it into collaborators where we're really trying to take the best data sets available and get the best answer we can. Because that involves taking many different models and figuring out where the differences are and how to bring them together. One of the things I've been most impressed with just at our first Buffalo meeting has been how much effort that we put not just into thinking about what we're doing, but into why we're doing it. And that this comes across both in the talks that people are giving, but particularly in the outreach and in a desire to explain to the general public why what we're doing is something we're really motivated and excited by and why we think we're just about to discover something interesting. I think maybe the advice that I would give to people that are thinking about going into science is there are a lot of really interesting problems out there. And the best thing you can do is read about interesting problems, hear about interesting problems, and think about interesting problems. And if you get a different answer than somebody else, think about why that is. Some of the time you're right.